right, good morning, I think, possibly still. Yeah? Well, welcome back, those of you who've come to see me for the second time this conference. It's lovely to see you. Have you been well? It feels like a lifetime. The rest of you, lovely to meet you. My name is Laura. Now, we're here today to talk about securing a buzzword. We're here to talk about the future security. Not quite as future as Internet of Things, and I'm pleased we're joined today by Kirk over here in the front row. This is called Assassinating the Expert. And this is where you point out the other security people in the room, so that if I have questions I struggle with, I'm sure he will be obliged and help too. Right, so today we're going to talk about containerization. There we go. We're going to talk about containerization. Yesterday, we talked about microservices. If you missed that talk, don't worry. You don't need to have known what was in that one to see this one today. And in fact, the video is already online, so you can go and catch up. But we're living in a very fast-changing world now. And there are some security defense techniques we really need to be bringing to our lives. And the containerized world is one of them. So those of you who know me, I apologize for this. And this isn't a sales pitch. I run a security firm called SafeStack. We are based in Sydney, Wellington, Auckland. We work with companies around the world, US, Europe, Asia-Pacific region, and we do this every day. We do security in DevOps, continuous integration, continuous deployment, or agile environments. We move at pace. So I'm speaking from experience. Today, the aim is not to sell to you. It's to save myself conversations. It's to put contents of my brain into your brain without breaking you. So hopefully we will succeed. This is the second part, as I mentioned, of a series, so please do follow along. As new technologies emerge, my plan is to continue this series. Architecture is actually, for once in our lives, one of the fastest areas we have in the development space. And that's unusual. Having done a lot of architecture work, it's normally actually quite slow-moving and genteel. But now it's aggressive and fast, so we kind of have to catch up. This slide is included not for you today. This slide is included for those who are going to find the video afterwards, or for you who, for whatever reason, come back to this talk and view it afterwards. This is a very fast-moving area. This content was written in the last 3 weeks, but in 3 months' time, the world may have changed. So today, we will mark it for the record as the 4th of September 2015. If you've reached this video or this recording, at any point after that, please bear in mind you may take things from this, but the world may have turned, so do your research. So, how many of you have been to an Azure Containerization is the Future talk this week? All right, a few of you, good, awesome. We have reached the point where containerization is not an idea anymore, it is commoditized. We have over 30 different varieties of container providers out there now. The big names, Red Hat, Microsoft, they all have a container service that is either already launched or is launching soon. We've got people, the unicorns of the industry, like Docker. How many of you have used Docker in your life at all? Okay, yeah. We have commodity containerization happening day to day in organizations big and small. How many of you are using containers in your day-to-day life already? Oh, only one or two, good, right. Okay, how many of you are planning to in the next couple of months? The rest of you just got really lost somewhere. HoloLens tour is somewhere in Sky City right now. Right. So what this talk is, and this is a 200 level talk, and while I will give you some background information on containers, we're not here to teach you what a container is. The lovely people at Docker, the lovely people at Kubernetes or the Open Container Initiative have lots of material for that. So please, if you feel the need to afterwards, go revisit some of that. And then you can re-watch this talk, and maybe you'll add a bit more value if there are gaps. I do apologize for that. So what are we going to do today? Well, we're going to do some fundamentals, not so much about how containers work, but about the differences between containerized environments and different, more traditional deployment spaces for us. And that's important because it's those differences that make the way we secure it more challenging or a little bit of a different approach. We're going to talk about how we prevent some of the common issues we're seeing emerge in containerized spaces. And then we're going to talk about detection, which, let's face it, let's remember that security is an asymmetric problem. There are way more motivated people out there trying to attack you than there are defending. We are probably going to get hacked, not as a sad thing, just as a reality. And so we've got to prepare and survive. Right, I need to understand this room a little bit more. Developers, raise your hand. Okay, infrastructure people. DevOps people. All right, okay, that's a good mix. Okay. There is opportunities for questions through this. If you do, feel the need, please do ask them, or there will be an opportunity at the end. So let's go through a little bit of background. Well, why did I get here? How did I end up talking about security and containerization? Well, I write software. I don't just consult. My firm also writes a product. And we had come from, back in my ill-gotten past, I am actually, or I was, a Red Hat certified technician. I managed Linux clusters. I was that cool kid. And that was my world. I was used to buying tin, spinning up new tin, building the operating system through whatever scripting language I was using at the time, applying some hardening techniques, off I go. I was used to doing this for years and years and years. So when I came to building software of my own, that's where I instantly went to. I was like, yeah, I'm just going to buy a box. And then I realized that I should probably consult the internet and see what the actual normal people did these days, because the world had turned. It had been 10 years. And it turns out this containerization thing had come along, and my security brain kicked in and told me that this was the scariest thing I'd ever seen. That there was this strange unicorn of a system where you could write 3 commands and suddenly you had infrastructure. And that terrified me as a security person. And if you're scared as a security person, that means you need to know more. That means there's a challenge here, because it's our job to understand all of the crazy technologies you lot go and find on the internet and decide you're going to use. Security people, it's our job to understand all of the nuances of it and then tell you how to do something on top of what you already know. So no challenge there, right? We've been using Docker, so for a little bit of clarity, this is not a Docker talk. However, many of my experiences come from a Docker-like environment. So be warned, if you are using something other than Docker, occasionally the verbs, the words might differ, so let's be careful there. In fact, language in general in this space is really hard, and I'm going to explain why. The words don't always mean what you think they mean. So my first lesson in securing a containerized environment is understanding what they actually mean by containerized environment. Because we're used to a container being a jug or a bucket. It has some walls. A container could be a room. It's got a lockable door. This one's got no windows, as it's particularly threatening. A container we're used to as being something that can contain, that can hold things in. That's not what that word means here. So let's talk about it. So most of us are migrating now from virtual machines to containers rather than from pure on-tin, 1 install per box kind of environments. So I'm not going to talk about the 1 install per box. We've kind of moved on from there. Let's talk about virtual machines compared to containers and what the difference is. The fundamental difference between virtual machine environment and a containerized environment is the level at which sharing happens. So in a virtual machine, you create an entire virtual operating system. It has a virtualized processor that's using part of the base machine's resources, but is virtualized and isolated. And on top of that, you install an entire operating system. So Linux or Microsoft or whatever stack you are familiar with, you install it inside your virtual machine. And that, to all intents and purposes, is contained. For many of us will have seen over the years there's been a few exploits here and there about jumping out of virtual machines and escaping these environments. But on the whole, the technology is quite mature. If you're in a virtual machine, it takes quite some intentional work to get outside of the virtual machine. And if something goes on in your virtual machine, it's isolated to that space. A container isn't a virtual machine. A container doesn't give you a virtualized processor, for example. It doesn't give you a full version of an operating system. A container gives you only the parts of the operating system you need to do the job you asked the container to do. So for example, in the tool I write, it has a database component, it has a session bus component, and scheduling component, so Celery and that kind of thing, Redis, and it has an application component. Now those, for me, are 3 separate containers. And each of those containers has different software inside it. The database layer only actually really needs Postgres. That's all it has. It has a few extra things that I've included so it can do some extra databasey things, but it doesn't have an operating system all of its own. It has a minimal set of calls to the underlying system and Postgres. And the same for my application stack, and the same for my session or message bus section of my container. Each of these little boxes is as little as possible to get the job done. The key is they're sharing that base processor. They are actually directly sharing the resources of the machine it's running on. And that's really significant. That's a big difference from virtual machines. Containers do not contain. You can pass from a container to the base operating system. You can read and write in that direction. That's different to virtual machines, which by default and in a secure configuration are isolated. You have to actually create these bridges in a virtual environment. These are all significant. Like I said, I'm not here to teach you all of the basics of containers. This was enough that we needed to cover today so that the rest makes sense. If you need to follow up any more, there's a lot of information out there. Things to note, container implementations really do vary. I tried to count how many different container systems I could find before this talk, and I got to 32 and found a cat video, and that was the end of it. I wasn't counting anymore. There are lots of them. That's really interesting because, as we know, whenever there's a divergent space with a new technology, we have different choices made by the development teams. So right now, we're in a position where sometimes your implementation will differ. So if you're in one containerized environment right now, migrating to another one may be complex or require additional work. I bring this up because there's work going on to solve this problem, and I think this is a project that's worth you following. Now, the funny thing is, on their website, their logo renders with the little man being a square. I don't understand why their SVG files actually have a person, but either way. So go check out the Open Container Initiative. That is all of these vendors of containerized software, Microsoft included, and they've heavily contributed in this space. They're going and they're defining the shared formats, the shared schemas, the shared rules in this space. They're trying to determine how we can make migration between containers easy, how we can make security something that is common. So if you want an authoritative, aggregated source of where this is traveling, this is where I would go and look and follow along. There's a lot of information out there, and it's only growing day by day. So let's begin. We've decided, our company has decided, we are doing containers. We're not going to debate the pros and cons. I'm not going to tell you whether you should or shouldn't. I've personally made the call for my firm that we are, in our prototypes and our new products, we're exploring this space. But you're going to make that call yourself. That's not for today. If you do end up there, though, we need to talk about how we're going to protect it. And the first one sounds really obvious, right? Check your privileges, check your permissions. It's what we say as security people all the time. But in this space, it's actually really significant. Because do you remember that part where I said we were sharing a processor? That's really significant. Permissions really matter when you are sharing the physical base resources of your machine. There is an opportunity to run as root by default in this space for everything you do. How many of you think that ends well historically? Yeah. Let's talk a little bit about Linux infrastructures for a second. I know we're in a Microsoft conference, but it seems Microsoft and the Linux world are playing nicely together, so I won't feel too bad about doing this. There is a core concern in many parts of the containerization world that we need to care about here, and that's called namespacing. Now, in the Linux world, namespacing was the way that we said that there are different processes and services that run on a machine or infrastructure. And we're going to group them in certain ways. And those groups are going to have different characteristics and behaviors and different permissions. And these namespaces and the fact we could have many of them with different profiles was really significant because it meant you could give things more permissions than others, and you could control it in some way. Now, in the containerized world at this point, there is no namespacing. Your processes are going to run in the same namespace as the user that your container is running as. So in a default Docker configuration, for example, that would be root. You're going to be running in the same namespace as the super user on your machine. That's significant. There is no user ID isolation. There is no way for you to segregate and isolate this. Now, there's a reason for this, and it's not all because they forgot. Actually, the security teams in this space are really very progressive. CoreOS, for example, have a really kick-ass security team. Led by Matthew Garrett. The Docker space has Diego, and they've been talking quite publicly about this stuff. The reason for it is we want to scale. The whole point of containerization, right, is that we suddenly overnight become successful. Reddit features our tool, we get on whatever, and suddenly our one user has turned into 50,000 and we want to scale quickly. One of the perks of containerization is that we can scale on demand. We can scale very quickly without having to buy more physical tin. We can scale in cloud environments. We can scale and segregate our applications. This is why it works very nicely with microservice architectures. You can't scale namespaces infinitely. That's not how Linux works. You run out of resource. So to enable you to scale, the namespace area became difficult to implement. Now, I know this is on many of the project's lists of things to address, but right now, when you choose your containerization software, check out namespacing. Check out how isolated your container is from the processes that are being run by your base operating system. Here's to clarify. Here's a nice little quote. When you come back to the slides, it should make it slightly clearer. So a process running as root ID 0, so this is not my quote, it's someone else's, is running with root level privileges. So that's always worth knowing. Remember that? You can read right to your operating system thing. You're doing that as root. If you are a sysadmin, this should be making you slightly scared. If you're not a sysadmin, please be scared. This means we can directly interact with the kernel, which in Linux world is like the brain of the organization. The Windows world, we're not so familiar with the language is different. I do apologize, as you come from Microsoft background, it all still applies, you just use different words. So what we want to do is reduce our permissions as soon as humanly possible. So that could mean reducing the permissions that your containerization software runs as to begin with. If you're running it in the cloud, that might not be possible. You may not be in control of your containerization software. But if you're running it on your own tin inside your organization or in rack space that you've purchased somewhere else, that could be an option. You could run with a user that has elevated privileges sufficient to run your containerization software rather than just pure root. That's not trivial. Just for the record. This is going to take some trial and error. This is going to need you to take away permissions from it, try and run it, and add them back one by one. And I really recommend, if you're doing this, to keep track of which permissions you're adding back, because these things are changing over time, and you're probably going to have to revisit those. You want to make sure that every level of your application, in fact, is choosing the right level of permission. So we've just talked about the base layer, the containerization software itself. But inside your application, so you're going to have a web server in one perhaps, you're going to have an application server of another kind in another, or a database server. You get to choose which user those run as inside those spaces. So please make sure any permission set you have, keep it to a minimum. Because containerization is kind of like Russian dolls. You have permissions within permissions within permissions. You have applications within applications within applications. And the beautiful thing as an attacker is I only actually need to win at one of those. And I'm going to go after the one you wrote, because nothing personal. You've got a much smaller security team than the layers below you. The next thing is nobody wants to build their own anymore. And that's a good thing, right? We want to go and find containers that have been pre-built for us. So we want to go and find them from an app store or similar. That's the model we've been taught to use now. And that's what we do as enterprises. We don't want to build our own if it's been done already. The trouble is, it's actually really very difficult right now to tell where the source of a container has come from. The visibility as to how a container has been configured and what it's running as and what it's got inside it is actually a relatively technical journey to go on. You can find, there are many, many places you can find these from. There's Docker Hub, there's many different marketplace type environments where you can go and download images from, or pre-made containers. Some of them will be free, some of them you have to pay for, some of them come from verified sources, some are labeled trusted. It's up to you as the person selecting it to know what you're looking for. Now, there are a few links included at the end of the slide deck, so I encourage you to go and check those out. One of them is to a Docker tool, so if you are in the Docker space, that lets you audit a container. It is a security audit tool, it's free, it's open source, it's on GitHub. That you can get a red or a green as to whether the configuration of that pre-built container is actually good or not compared to security best practice. Not all container infrastructure has that ability yet. So remember, you are trusting whoever's provided the App Store environment or the download environment to verify those boxes for you. Now, how's that been working out in the Android Play space right now? the answer is it's not been working out all that well. Because what happens is as the popularity of containerization technology increases, much like apps, the demand on the people verifying these apps goes up. And they can't clone each other. There aren't that many people doing this. So they have to do less rigorous checks, or they do checks on samples. So you can't rely or put all of the risk onto the organization that you're downloading from. You need to, once you download, take steps to verify yourself. Now, part of that is starting to be done with signing pre-built containers. Okay? So people like Microsoft or Ubuntu or Red Hat, they're all starting to have these trusted repositories, trusted images, and they've signed them. Now, that's an awesome idea. Signing, just in general, is quite a useful technique. It's using bits of crypto. There's crazy maths going on. And if it's done well, it gives you an idea that it was created and not changed since somebody used it. However, there's a quirk. There's always a quirk. In this space at the moment, at this point in time, it will check that it is signed. If you do the sign checking thing, it won't tell you if it's signed by the right person or if that key is still valid. These are kind of fundamental checks. So, yes, it's signed. That's awesome. Fantastic. Step one complete. But don't run it. Check that it's signed by the right person. Check that the signature is valid, and go and check these repositories should publish what their signatures should look like. They should be able to tell you authoritatively what you're looking for. So you have to put a step in that says, I've downloaded a new image. Is it signed? Is it signed by the right people, and is it valid? Okay? And that process will be more manual in some instances than in others. Hopefully it will all become automated and we don't have to care. But right now, that's manual, so please remember to do it. Then we can run it. Only then. And please, I know there's at least one of you thinking, but it's a test environment. It doesn't matter. But it does. Because the realities of the world we live in and the development spaces we live in is that things that enter the test or dev environments, we kind of get used to them working there, and we like using these things that we've got in dev and test. So there's a gravitational force that moves things from dev and test through to production. It happens. They're just naturally. It's like test data. That has a gravitational force that moves in the opposite direction. It moves from production to every laptop in your organization. So remember this. Even if you're okay with it not being signed and it not being verified because it's just on your dev laptop and it's just for science, remember, the processes you're doing day to day in your development environment, they're going to reflect, they're going to move towards your production. So don't cause yourself pain later by putting something that's going to move that way. Do these checks even when it's just for dev. And if you find an image that looks like it's verified, looks like it's trusted, but these things are not right, the signing is not right, you're not able to follow this process, it doesn't look good, talk about it, report it. Don't just go, oh, that's a bit creepy, I'm just not sure. Because one of the biggest challenges in these trusted repositories is finding out when it's gone wrong. And there's very little two-way feedback. We often say publicly on Twitter, oh my God, it's gone wrong. But we don't go, oh, hey, vendor, you just give me this and this looks completely suspicious. The reason we do that is twofold. Firstly, they need to know if it is suspicious. And if it's not suspicious, but the process was confusing and you didn't really understand what to look for, it means their process is wrong. It means their documentation needs improving, and it means that we need to do a bit of education. So please do feed this stuff back. In a highly emergent technology space like this one, where we've got a lot of new things happening at once, if we don't feed back our stuff into these ecosystems, they never get any more secure or any better. How many of you have ever been involved with vulnerability management as part of your job? How many of you don't have a clue what that even means? Okay, let's recap a little bit about vulnerability management. I'll reuse my puppy analogy from yesterday because it's quick and easy. Whenever you choose a technology, it's like getting a puppy. It's awesome, you're excited, you've got a new technology, yay. And you get to do new things because you've got a puppy, you can go walk in the park. But you've got a puppy now, and your puppy is going to poop on the carpet at least once a month. That is vulnerability management, dealing with the unexpected side effects of having a fun thing in your life. So if you've got one technology and you only have to monitor that one technology for updates, then that's easy. You just chase around after it on the internet and look. But how many of you know how many technologies are right now? Yeah, you're either super awesome or lying. So Even tiny organizations with like 2 or 3 developers can wind up with 112 plus technologies in their stack, talking about frameworks, libraries, modules, and even if it's come from, you know, your core language repository, so it's come directly from Microsoft or it's come directly from Oracle and Java, there are still going to be vulnerabilities come through in those. We still have to manage things that have come from these repositories. So much like puppies, when we have many technologies, we have to clean up a lot of mess. So that's vulnerability management in a nutshell. It's the burden of playing. It's the cost, the table stakes. Now, patching the stack in a containerized environment is actually a different beast. So in a traditional environment where you run a host or a virtual machine, you have an operating system. And most of the time, that comes with a lovely option that says, auto-update, please. And you tick the box if you're lucky, and off it goes. If not, you could tick the box that says, just tell me when there's updates, and nag me with that little irritating thing and threaten to shut down my computer, which is the Windows style of patching. That's not how it works in containerized space. In container space, we have to layer patches upon patches upon patches. We have to patch the base operating system. So our container actually has to run on something. So your containerized system, the container daemon, if you will, is running on an operating system. This isn't just running on thin air and magic and fairy dust. So you've got a base operating system to manage. You've then got all the installed applications you put on that machine, because I'm betting you didn't just install the containerization software, you also put, you know, a web browser and probably a GUI and stuff on there, because we do that on servers, I don't know why. You've probably installed a few extra services, maybe a monitoring agent, logging agents, that kind of thing. They all need patching too. Then you've built some containers, and every single one of those containers needs updating, so the containerization software would need updating. And then you put more software inside the containers, and all of that needs patching too. So what you end up with is quite a cascade for vulnerability management, and this is hard. I'm not saying this is easy at all. But we need to be aware of it. Just because it's hard, it doesn't mean that we have to go, not doing it. We have to make sure we make this as easy as possible. So that means doing some of the following. It means at your base operating system, turn on auto updates if you can. At your base operating system, don't install much on it. Because the less you have, the less you have to patch. Now, why am I telling this to a room that I know is 50% developers? Because DevOps. Whether we like it or not, developers and infrastructure are coming closer and closer and closer together. And the distinction between who patches each part of this stack is becoming blurry. So your infrastructure team might be familiar with the operating system layer and even some of the installed applications. But do they know what's inside your application stack? Do they know what you've put inside your containers? Do they know how to patch that and update it? And do they know the ripple effect of doing it? Is there a process you have to go to test and check this is sensible? We need to understand this as both developers and infrastructure people because we've got to work together on it. Your infrastructure people, if you make them do this all on their own without any help, they're awesome people, but they will engineer the hell out of this problem. And this is going to be a very different landscape than you developers are used to working in. Infrastructure people, if you don't get close to your developers and understand them, they're like kids in candy stores at the moment. Microservices says they can use any technology they like for any project. Now, your technology stack is going to breed like rabbits. You're not going to be able to keep up, so you need to work together to understand it and kind of minimize how complex this is going to be. And you need to have a process for understanding which container is at which state, because you might end up having containers that contain your new versions of software that you've updated and you're running on new versions, and containers that run your old versions. And how are you going to tell the difference between them? It's very difficult. You need to build mechanisms where you can tell what's inside the box, even if the box doesn't have a nice operating system and a view status option or a see what's inside magic button. Sadly, and this is my least favorite part of securing containers right now at this point in time, the way to secure containers is actually to isolate them. And this breaks some of the ideology? Yay, new words. Ideology of containerization. What do I mean by that? I mean, we're used to virtual machines. We understand the isolation is fairly mature, and we're used to that. The way to isolate containers right now and to remove that risk, do you remember that part where I said you're running as root and you can talk to the base operating system? Just for the record, you don't want that happening, that's bad. So to remove that risk, the way to do it is to run your containers inside a virtual machine. So do you remember that layers upon layers upon layers? We just added a new one. Russian dolls are getting really teeny tiny at this point. We've got our base operating system. We've got a virtualization layer that we've got on top. So whether that's Hyper-V or whether it's some of the other VMware-based stacks, I don't care. I genuinely don't. I'm not here to tell you which technology to choose, but choose a virtualization layer. Inside that VM, you can run dozens of containers. I have no problem with you running a small army of containers inside your virtual machine. But it's that virtual machine that is containing it for you. It's not the containers. So use virtualization, tools we're quite familiar with, to mitigate the risk that containerization hasn't gotten to yet. I'm not saying this technique is going to work forever, but right now, this is a really good way to keep this risk separated. If you're going to do this, please use an enterprise-grade host or operating system to do it on. Now, what does that actually mean? It means that not all operating systems are equal, and not all environments are equal. And when we go DevOps, and we go there hard, and we're really excited, we normally kind of go, right, I just need something simple, and we download things quick and easy, and we just get on with it. Now, many of those are free versions or open source versions. That's great. They're fantastic tools. But if you're in an enterprise environment and something goes horribly wrong with that layer, you probably want to pay someone for support because you're an enterprise and you have money for these things and probably know people. So use an enterprise-based host. So good hardware, because good hardware will scale. Remember, you're sharing that little tiny processor, that little processor that's on that physical machine. That's being shared quite heavily now. So use good kit. And then manage it like it is an enterprise-grade host. Don't just go Docker wild. Don't just go, I'm going to swarm all the things. Make sure you're putting change control in, that you're understanding when you're adding new containers what you're adding and what the risk is of each of them. Understand if you've put virtualization on top, what the risks are there and what the complications are for workflows. Now, why do I mention workflows? People are like water. Developers particularly are very creative when it comes to working around obstacles. If we put together an operating system layering solution to get to our containers to a safe place, and we make it incredibly painful for people to deploy or to manage their boxes or to upgrade or do any of the things they want to do day to day, they're going to work around us in the most horrendous fashions. Part of security now isn't actually being the no person. It's planning workflows for people so they can do their job. It's allowing people to do things. It's saying yes, but in a controlled way. So that comes into enterprise management. Enterprise management isn't about saying no, even though we want to believe it is. It's about doing it in a way we can scale and is easy and that we can repeat. So apply that here too. Let's go back to that virtual machine or to the physical host if you choose not to virtualize. Please, if you do nothing else, stop installing things on your hosts. The minimum you actually need to get going with containerization is the containerization software and its dependencies. So, let's accept dependencies are a thing. We have to kind of meet them. You need to be able to get onto the box. So SSH, probably a good choice. Don't recommend FTP for this, just saying. And you need to monitor it somehow. So if you come from the good old days, that could be a Nagios agent. If you come from a more modern type, there are many hipster words you could use for this. Whatever your logging and aggregation agent is, your health monitoring, put that there. That's it. Do not install anything else. The job of that host is purely to run the applications you've put in your containers. That is all it is there to do. Do not use it for other things. Do not install things because, it's not using much resource. Just don't. That patching pyramid that I showed you is part of the reason. The other reason that is attack surface limitation is really important. You're doing something that has risk involved with it. And risk involves us having lots of different ways an attacker could possibly cause us damage or steal our information or somehow interfere with what we're trying to do day to day. Keeping this attack surface small, so opening the fewest ports we can, exposing the least amount of it to the internet, installing the least applications, keeps us safe. So I'm not saying go and buy 1 million boxes now because you can only do one thing per box. I'm just saying if one of your boxes is doing containerization, keep that one pure. Oh, whoops. It's all got excited. So you should be getting this layered picture now. Containerization isn't a standalone panacea. It is a way of layering, of segmentation, of isolation in the softest sense of the word isolation. And we need to do defense at every stage now. Your application, thankfully, is still the most risky part of your infrastructure. So that's good news. So for those of you who went to the social network security talk earlier, or have seen any of the range of application level security talks out there, you're familiar with the types of vulnerabilities we are breeding into our applications day to day. We don't always mean to, but they are cropping up still. They're still an issue. And your application is still going to be the easiest part of this to attack. It's the most public. But it's not the only part. Your containerization layer, the orchestration layer around it, is going to be an attack vector. What if you put containers you built, so your application, could you be deploying that one day into a Docker Hub or a container store? Are people going to try and imitate and put out containers that connect to your services? We've got a lot of new attack vectors now, in fact. And we need to understand them. How many of you have ever threat modeled anything or done a risk assessment, even if it was informal? Okay, I'm going to ask the same question to a group of people next year, and I'm hoping all of you raise your hand. Because threat assessment isn't about some kind of dark art they teach you in security school and you get a cape and a badge. It's about standing back, looking at the application, the system you've built, and the crazy concoction of technologies around it, and going, right, if I was having a bad day and feeling a little bit peeved, or if I was feeling poor and needed money, how am I going to try and get that from this system? And that's trying to put yourself in the shoes of politically motivated people, people who want to get money or stuff, people who want to extort you or blackmail you, people who want to steal your company secrets, people who want to, sorry, I get a little excited when I talk about attacking people, but people who want to do bad things to people. You need to practice actively thinking in that way, particularly in the containerization space, because you've got a very fragmented infrastructure now, and there's many, many new techniques for attacking that are coming through. I want you to get used to challenging and going, right, if I'm a bad person, can I query that container all on its own? What happens? What happens if I prod it in that way? What happens if I prod this layer of my infrastructure now? Because we've got these layers, and everyone knows layers don't always work well in terms of stability and whatnot. So if you're not feeling thoroughly miserable with containerization already, and you shouldn't be, it really is a very useful tool to helping with some of our new architecture choices like microservices. But we have to go in wisely. So how are we actually going to protect ourselves? How are we going to notice when bad things are happening? Well, it seems like common sense, right? But we need to monitor it. Now, do you remember that layering we did a little while ago that had an installed base layer operating system, and it had the apps on top, and then it had a containerization layer, and then it had your app? You need monitoring every single point of that stack. Now, I work with a lot of organizations, and monitoring can be quite hard. We're used to monitoring for functionality bugs in our software, so sending them off to Raygun or whatever, but we're not really used to bringing so many different layers of logs together into one place. And remember, these aren't all the layers. We've also got a whole layer we didn't mention. We've got the stuff at our border. We've got web application firewalls. We've got any kind of proxying device that is somehow load balancing our traffic or otherwise aggregating or changing the flow. We need to be monitoring all of that environment. And I'm going to put it out there. How many of you look at your logs ever? How many of you looked at a log in the last 2 days? How many of you looked at a log in the last 2 days because there wasn't, when there wasn't a problem? Nothing was burning, you chose to look at logs. Okay, these people are worth hiring. Rest of you, you got work to do. We are terrible at logging. We can create logs, that's easy. Turn on button, get bacon. Easy. Logs will appear. They will spew into a void of disk space, and they will keep there forever if you configure them right. But we don't ever go back and look at them. In this environment particularly, in an environment where we have segregated things heavily, logging is really important. And not just logging, we don't want to be looking in 27 different places inside each container for our logs. We want this logging in one centralized place. Now that has two consequences really. Firstly, you're going to have a lot of logs. And anyone who's using any kind of SIEM or log aggregation tool that charges you by the gig is going to weep silently at this point, because suddenly what you were facing with bandwidth and usage is going to go through the roof. So consider your licensing model and what logging services you're using and their pricing models when you start doing this. Because you don't want to have to turn it off because somebody said, oh, no, we can't pay the bill, we can't afford this. Choose one that scales their pricing model with the way you're going to use it. The other reason we need to care, other than just having finite money, is these logs all look very different to each other. These logs all do tell us slightly different things. We don't want to have to go and find them all and then interpret them all and correlate them all. Things like date stamps and things become challenging. Actually understanding the flow, what triggered what. Now, as an attacker, why do you think I really like this? Why is this important to me? Why am I mentioning it? Because a few of these things are really valuable to me as an attacker, and one thing, the overarching thing, is super valuable. Your logging is the holy grail for me. If you've got your centralized logging server getting all this information in one place, that's going to tell me everything I need to know about a system. So you don't need to just log these things. You've got to keep your logs safe. How many of you know that you could probably edit the logs in your environment if you went in with a text editor? Yeah? Yeah, I've got logs in my environment. I know I like that. We need to move away from that. We need to make sure our logging and our monitoring is secure because they are our only record. They're our only authority in this space. There's a really high impact of compromise in the containerized environments. By compromising a container, because of that shared access that we were talking about, because of the namespace thing, because we're running as root, hopefully not, but many containers do, we compromise a container, that little teeny tiny box, it's doing one tiny microservice, we can access a privileged process on the core machine. Hopefully in a virtual machine, but if it's on your base operating system, suddenly we're talking to processes on a proper machine on your network. If we can do that, we can compromise the host. Now, once we've compromised the host, that is a scary path forwards. So as an attacker, you're looking at things like pivoting through a network. So if you've compromised a single host, think of it like a little treasure hunt. You get in through one avenue and you go, wow, this is exciting, but you see several doors and you're like, oh, what can I find through those? Your networks are that for an attacker. They are a stepping stone combination of different hosts that each have different secrets and treasure on them. So by compromising a container at the current point without the proper protections, we could compromise our base host, we could compromise a wider network. That's quite scary. Now, that's not unusual. You could do that through a web application if it's poorly deployed. But in this case, what we're saying, the scale has changed. If you've got one application server with one app on, that's fine. If you've got 30 containers all running different things, that's a whole new, wider picture of the potential for host compromise. So one thing you need to do is seek some assurance. Now, here's the open book. I run a security firm. We do not sell pen testing. Please do not come and ask me to pen test your microservices or your containers. I don't do it. We do consulting and advisory and training. There are many firms who do this very well, though. There are many specialists you could hire as internal people to do this. But frequently changing architectures like this, ones that are massively distributed, need frequently changing testing. They need to be tested all the time. Most of the time, the guidance we give at the moment for this is pen test your architecture once per year or on significant change. Wonderful. Now, in my little world, significant change is happening for many of my clients multiple times a day. Now, if a penetration test costs, say, $20,000, let's do some remedial maths, and we're doing, say, 3 significant changes a day for, say, 200 days a year, because we have holidays and weekends, I'm going to say that's gajillions of dollars. That's a technical term. You probably don't want to be outsourcing that all of the time. And I'm going to tell you a secret. You don't need to. You do need to engage a pen test firm and get some proper assurance on intervals or on some defined metric because you're going to be compliant and things, and they're going to need it. But you can do a lot of this yourself. You can audit configurations. Don't audit the ones you wrote. You'll never actually see any problems with it. It has the same paradox as code review, whereby if you review 10,000 lines of code, it'll look fine. If you review 10, you'll find 20 issues with it. So don't audit your own stuff, but audit your host configurations, your container files. Those little tiny scripts that build the boxes, whether you are deploying through Chef or Puppet or Docker Compose or whatever tool you're using, they can all be audited. And you can look at the best practices. You could write a script that compares it. That's exactly what the Docker audit tool is. It's a script that compares to best practice. You can fuzz your containers. Now, I haven't got the fuzzing definition in this deck, but it basically means to insert big amounts of unstructured data or unexpected data into your container. What you want to do is hit that tiny little container as hard as you can in as many creative ways and hope it falls over. Because when it falls over, you learn things. So get used to doing bad things to your containers, treating them in ways they don't expect, trying to access resources that you don't expect you should be able to access. You'll need to do design reviews. You should be doing this anyway. And like I said, I want you to all start doing threat assessment. Don't get tied up in the formality. Start thinking about the bad places things could happen. You need API and endpoint testing. So if you're using your containerization for an endpoint out on the internet, you need some good testing over that. Now, you can do that through your automated test suites you're writing yourself. You could use something like OWASP Zap to add a vulnerability assessment layer to it. There's a whole load of tools you could do to do some of this yourself before you get a penetration testing team in, because you're not going to be able to afford the time or the money to do that daily at the moment. Web app penetration testing has been around for like an age now. You should already be doing it. How many of you work on an app that's never been pen tested? Okay, one of you's honest. Many of you don't know. Most of the time, your firms will have kept the knowledge of whether it's been pen tested secret because they don't want you to know that they've probably got an ugly baby. Go ask someone. If you're not sure, go ask. Because you know what? If you're inside the organization, you're supposed to be trusted. And the only way you can resolve these issues and make sure they don't happen again is actually seeing the results. So I'm really fed up of organizations not sharing their pen testing results at any layer with their staff. They've employed you, they should trust you, and you have a right to see this stuff. So let's wrap it all together. Today we learned a bit about the fundamentals of containers and why they differ from things like virtual machines. We learned a bit about namespaces, about who we run as, and we learned that there's an open container initiative that's going to change these things and hopefully make them easier and more standardized. We learned about some prevention techniques, and they're all summarized on a nice slide for you, so you don't have to read giant slide decks, the TLDR version. We learned that we need to do this across the board, and this is going to be quite hard to begin with. This technology is not mature enough. This will be simple and automated. But if we share how we're doing it, we're going to get this quite rigorous quite quickly. So I encourage you not just to listen to people like me, but to go do this and then share your experiences. Because I want to know not just when it's working and what worked well, because we always talk about that. I want to know when you screw up. I want to know that time when you went, oh, so I totally thought this configuration option meant this, but actually the world ended. Those are the most valuable lessons we can share as a community and share them in a safe way that actually it's okay to do that. We talked about detection. You're all going to start monitoring logs now. You all look enthusiastic and eager and like you wanted homework, so good luck with that. And you're going to talk about assurance. You're going to start testing all of these layers. That means there's going to be more testing in your environment than development, hopefully, which is a good thing. More testing, the more bugs we find, the more issues we find, the more we understand the gray areas and the edge cases. As I promised, there's a couple of things you should probably go and look at. So the top one is the container security cheat sheet. It actually goes across all container types, so it's not specific to Docker or Kubernetes or whatever. And it goes over 12 things you should probably go and look at. It's one sheet of A4, so you could go print it out and put it on your desk. I've included it, and I didn't write it. I included it because I think it's good resources, and I like to share things other people wrote too. I think that's important. The Docker Security Benchmark tool is a really interesting example of what we can build in relatively simple ways to help in this space. So if you feel like contributing to open source, there's a lot of this stuff going on at the moment that you could go and dabble a finger in. Right. My other talk already happened. You can find the video on the internet. I don't like these slides, but Microsoft likes having them. So there we go. That's a slide. That's another one. That's another one. Awesome. So traditional rules apply. 6 on the feedback form, please. All the apostrophes and double pluses. And if you can make it Spring JavaScript, I'm super happy. OK. If you have any questions, I would be more than delighted to answer them. But if not, thank you very much for coming. And good luck with this. This is an exciting space, and I want you to do it safely and securely and enjoy yourself doing it.